Skewness is a measure of asymmetry of a probability distribution. In a perfect symmetrical distribution, the mean, the median, and the mode would be all the same at the same point, and the skewness would be 0. However, when this measure different, it indicates the skewness in the distribution. We have a positive skewness when we have the mean greater than the median, greater than the mode. The distribution is skewed to the right with a longer right tail. So start with the mean. So here's your distribution. The mean is greater than the median, greater than the mode. So then we have this kind of distribution. So it's skewed to the right. Now when it's skewed to the left, we have the mode is greater than the median. The mode is greater than the median, greater than the mean. So here's the mean. The mean is the smallest. Then you get the median, and you get the mode. So your distribution kind of go skewed this way. Right, so this is the negative skewness with the longer left tail. Interpretation. The mean, if the mean is greater than the median, it suggests that the presence of high value pulling the distribution to the right. If the mean is less than the median, it suggests that the presence of the lower value pulling the distribution to the left. The median is less affected by extreme value than the mean. If the median is greater than the mean, it indicates a negative skewness distribution. If the median is less than the mean, it indicates a positive skew distribution. The mode is influenced by the frequency of the value of the distribution. If the mode is greater than the mean and the median, it suggests a positive skewness. If the mode is less than the median and the mean, it suggests a negatively skewed distribution. So here we can take a look at the example. Here we have the positive skewness when the mean is greater than the median and greater than the mode. And you have a negative skewness when the mean is less than the median and less than the mode. A positive skewness indicates a distribution with the tail to the right, where the mean is pulled in the direction of the higher value. The negative skewness indicates the distribution with the tail to the left, where the mean is pulled by the direction of the lower value. The relationship between the mean, median, and mode help identify the direction and degree of skewness in a distribution. So let's take a look at a couple examples. Determine whether the distribution is symmetric, positive skew, or negative skew. So looking at the first case, as you can see, this is a perfect distribution. So we have a symmetric. In the next case, we look like we have the longer left tail. If we have a longer left tail, because we have a longer left tail, this is a it is skewed to the right, right? Actually, it's skewed to the left because we have the longer left tail. So here we get negative skew, negative skewness, longer left tail. And here we have the positive skew. We have a longer right skew, right tail. Yep. Let's talk about the measure of the spread of the data. A testing lab wished to test two brands of outdoor paint to see how long each will last before fading. They take sample of 1 of 10 individual gallons of each brand. The result is in months are given, brand A and brand B. We want to find the mean for each group. Then we'll make the dot plot for each brand of paint. Okay. I will use our calculator to calculate the mean for each group. And using calculator, I calculate that the average time that the paint will last before fading for brand A is equal to 35 months. And for brand B, it's also 35 months. So let's go ahead and make the dot plot for each brand of paint. Okay, so we have brand A. We start with brand A first. And we try to create our same number line. And we make it match. So the highest number here is 60. So 60, 0, 30, 15, 45, 5, 10, 20, 25, 35, 40, 50, 55. Okay, so brand A, we have a 10. So the first dot, 60, 50, 30, 40, 20, 25, 45, 15, and 55. So look like they're not really much of a spread here, right? It's kind of like everywhere. Let's use the same number line for brand B. And let me just take this number line down. Again, 30, 5, 10, 15, 20, So first brand is 35, brand B. The first paint faded at 35 months, then 45, then 30, 35. Okay. So 35, 45, 30, 35, 40, 25, 30, 35, 40, 35. So note that most of the paint that from brand B is faded in between, in this short map, in this between anywhere 25 to 45 months. The data doesn't spread a lot. Okay, so how do we decide which paint to buy, which one is better, right? And so what we want to do with this type of thing is we want to calculate how spread the data is. Does it even make a difference to buy a different type of paint just so that it take longer time to fade, or it take less time to fade, depending on the price and everything else. So you want to see how spread this data is to make your decision. The population variance and standard deviation. The population variance is the average of the square of the distance each value is from the mean. The symbol for the population variance is sigma square. The formula for the population variance is sigma square equal to sigma times x minus mu square divided by n, where mu is the mean of the population and n is the number of sample, the size of the population. The procedure table. To calculate the variance in the population standard deviation, first you find the mean for the data. You find the deviation for each data value. Then you square the deviation, find the sum of the square, divide by n to get the variance. Take the square root of variance to get the standard deviation. The rounding rule for standard deviation is the same as that for the mean. The final answer should be rounded to one more decimal place than that of the original data. So let's find the variance and standard deviation for the data set for the brand A pen. So we'll use the aid of our calculator. So first thing first, I'll go ahead and enter in the list of value x into list 1. So this essentially, so what I'll do, this is my list 1. This is my list 2. And this will be list 3. I'll use the list 1 to calculate the mean, mu. Then I will use list 2 to calculate the list 2 column, then list 3. So how do we do that? So stat, we go edit, lead this up, and let's go ahead and enter the data we have into list 1. Now I need to calculate the average, need to calculate the mean. So stat and calculate. So the average here is 35. So in list 2 will equal to list 1 minus 35. And I will enter that in. With list 2, the rule list 2 equal to list 1 minus mu, that is 35. Now I get the set of number. I will write this in. It is negative 25, 25, 15, negative 5, negative 15, 15, 5, negative 15, negative 10, positive 10, negative 20, and 20. Now in list 3 is equal to list 2 square. So we do that. So list 2 square. And here our result. I will write that into my third column. Sit 25, 225, 25, 25, 225, 100, 100, 400, 400. Now, the rule to calculate the variance sigma square is equal to the sum of x minus mu square divided by n. N is the number of data. Okay, I can use the calculator to calculate the sum of list 3. I can do it as follows. I can get out of here, go stat, and we calculate list 3. So the sum is 2,750. And n is the number of data, so that's 10. So sigma square is 275. So the variance is 275. The standard deviation equal to square root of 275, and that is 16.6. So this means that we have a pretty wide spread from the average month that it takes for the pen to fade to the soonest or the latest the time for the pen to fade. This is a very wide spread. So let's repeat this calculation, but for the data set for the brand in part B, see what happened. So let's repeat. This example for pen B. Okay, and to do that, I'll go ahead and use the calculator. I will tell you how to do that. So the first thing, I will enter the x value to list 1. Second, we calculate the variance and standard deviation using your calculator. So let's go ahead and do that. So let's go back to our data for pen B. And we will clear list 1, list 2, and list 3. Let's see, we just do the whole thing using the calculator. Okay. So 35, 45, 30, 35, 40, 25, 30, 35, 40, and 35. We then spread stat and we calculate list 1. So here we told that the average is 35. The standard deviation is the sigma. Sigma x is 5.47, so 5.5. So here we get this is 5.5, which means the variance is 5.5 square. and that is 30.25. Okay. So here that you can compare the standard deviation between brand A and brand B. This telling us the brand B of pen have more consistent than brand A because the standard deviation is smaller. So that was the standard deviation for the population. Now what happens when we use a sample? So how do we estimate that? The sample variance and standard deviation. The formula for sample variance denoted by S squared is calculated by S equal to sum of x minus x bar divided by n minus 1, where x is individual value, x bar is the same sample mean, and n is the sample size. The standard deviation is the square root of the sample variance, where S equal to square root of S squared. Let's take a look at an example. The increase in cents in cigarette tax for 17 states in a 6-month period is given. We want to find the range, the variance, the standard deviation of the data. Well, the range is equal to the max value minus the mean value. The maximum value here is 69. The minimum value looks like this 8. So 61. So that is in the range of 61 cents. We can calculate the variance and standard deviation using the calculator, and note that this is x. Okay, when you use your calculator, the two things, there's S and there's sigma. You need to pay attention to which one to use. So here we have a sample size, so we will look for the S. Again, I will enter this data value into the list 1. And we'll tell our calculator to give us the variance for this one. So here we can see that the variance is so we see that the standard deviation is 18.08, so that is 0.1. The variance is 18.1 square, and that is 327.61. So how do we calculate the variance and standard deviation for a group of data? Yes, we have the formula S squared for the group of data. Note that here we have, so S squared equal n times the sum of the frequency times the midpoint square minus the sum of the frequency times the midpoint, then square it. So pay attention to that small change in the formula of where the square is sitting. Divide by n times n plus 1, n minus 1. The standard deviation is the same, that is just S equal S square root of S squared. The procedure for finding sample variance and standard deviation for group data. You make the table as shown. You have class, frequency, we find the midpoint. We calculate the frequency times the midpoint. And we calculate the frequency times the midpoint square. Okay. And then we find the sum and product for the square midpoint. We will use this into our formulas. So here you have the class limit and the frequency. So first thing first, we need to find the midpoint. The midpoint here is 5, 10, 15, 20, 25. Okay. We will enter this into our list 1 and list 2. This is list 3. List 3 equal list 1 times list 2. And in list 4, this equal to list 1 times list 2 square. When you enter that into your calculator, you get the following: 30, 70, 45, 60, 25, and we will calculate the total, 230. Here we get 150, 700, 675, 1200, 625. Again, the total here is 3350. We will plug this into our formula. S is equal N. N is the total of the frequency, that is 20, times the sum of the frequency times x and times the midpoint square, so 3350 minus 230 square, divide by 20 times 20 minus 1. So S is equal to 37.1. So this is S squared. So the standard deviation is equal to square root of 37.1, and that is 6.1. Talk about the coefficient of variation. The standard deviation can only use to compare samples whose units are the same and have approximate the same mean. Say, for example, earlier we compared pen A and B. They have the same mean. Their variation, the standard derivation is different, so we can compare them. The coefficient of variation, denoted by C var, is the standard deviation by the mean. The result expressed as percentages. For example, C var equals S divided by X multiplied by 100%. For population, we have sigma divided by mu multiplied by 100%. Let's take a look at the example. The average number of days that construction workers miss per year is 11. The standard deviation is 2.3. The average of days that factory workers miss per year is 8, with standard deviation of 1.8. Which class is more variable in terms of days missed? Okay, so let's calculate C var for construction worker. That equal to the standard deviation divided by the average multiplied by 100%, and that is 20.9. Calculate the variation for the factory worker. So 1.8 divided by 8 times 100. that is 22.5%. So this meant that the time that the factory worker missed per year, the data set have more variation than the time that the construction worker missed per year. Another estimation that we use is the range of thumb. The range can be used to approximate standard deviation. It's called the range of thumb. The rough estimate for the standard deviation, S, is the range divided by 4. So estimate the standard deviation for 2 brands of pen and compare the answer to the calculated standard deviation. So we have brand A. So originally in our data, the range is 60 minus 10 divided by 4. So this is about 12.5 months. And our SA, or sigma A, that we calculated earlier is 16.6. Okay. For brand B, the range was 45 minus 25 divided by 4. So this is about 5 months. And the standard deviation that we calculated earlier was 5.5. So that's pretty close approximation. Okay. The Chebyshev theorem. The variation and standard deviation can be used to determine the spread of dispersion of a variable that is large. That is, the larger the variance or standard deviation, the more data value are dispersed. The Chebyshev developed by Russian mathematician Chebyshev specify the proportion of the spread of the term of the data standard deviation. So here's the theorem. The proportion of value from a data set will fall within k standard deviation of the mean will be at least 1 minus 1 over k squared, where k is the number greater than 1 and k not necessarily be an integer. For example, the mean price house in a certain neighborhood is 50,000 and the standard deviation is 10,000. Find the price range for which at least 75% of the house will sell. So we first need to figure out what is k. We know that the percentage, how many standard deviation we are looking at to be fit in 75% of the house will sell. So 75% will be 1 minus 1 over k squared equal to 0.75. We will solve for k. Solving for k, we get k equal to. So this meant that the house in the neighborhood will fall within 2 standard deviation. So if the mean is 50,000 and the standard deviation is 10,000, then the house price is between 50k minus 2 times 10k, that is 30k, and 50k plus 2 times 10k, that is 70k. So the house price is between 30,000 to 70,000. The empirical or normal rule. The Chebyshev theorem applies to any distribution regardless of its shape. However, when a distribution is bell-shaped, or what is called as normal, the following statement would make up the empirical rule are true. Approximately 68% of the data will fall within 1 standard deviation of the mean. 95% of data value will fall within 2 standard deviations of the mean, and 99.7% of the data value will fall within 3 standard deviations of the mean. Now, so if we have a data set and we told that it is normal, then we will apply empirical rule. Whereas here we are in Chebyshev theorem, we don't know whether the data set is normal or not.